Hey guys, wanted to talk through your sample quiz with you to help you prepare for your quiz tomorrow. So our first question, which of the following is -4? And we're talking about our different types of numbers. So remember, natural numbers are like the ones you count with, 1, 2, 3, 4. Whole numbers add in 0, so 0, 1, 2, 3, 4. Integers are positive and negative whole numbers. So that's going to be like -4, -3, -2, -1, 0, 1, 2, 3, 4. So you can see -4 is definitely an integer. Rational is anything that can be written as a ratio. So -4/1 could be written as a ratio. Now remember, it's either rational or irrational, not both. So irrational is when it is non-repeating and non-terminating. -4 definitely terminates. And it is real because it doesn't have any imaginaries in it. All right, then for number 2, you'll notice that this decimal that we have, the little dots here say that it keeps right on going. It doesn't stop. And you'll notice there's no repeating pattern to it. So that is the two characteristics of an irrational number, non-repeating and non-terminating. And again, it is real because it doesn't have an imaginary part with it. All right, then for number 3, using order of operations. So first off, we're going to do parentheses or grouping symbols. And so we're going to work inside these parentheses right here, still following order of operations. So inside these parentheses, I would do exponents. 4 squared is 16. And then I would do 16 minus 4 is 12. All right, so I've cleared my parentheses. Now I'm going to go back and see I don't have any other parentheses. I don't have any exponents. So I'm going to do multiplication and division at the same time from left to right. So I don't do multiplication first and then division. So I'm going to do 12 divided by 2 is 6. So now I've got 6 times 3 plus 6 times 2. And then I'm going to do 6 times 3 is 18, still doing my multiplication and division from left to right. I'm not going to add the 3 and the 6 because I have to do this multiplication first. So 6 times 2 would be 12. And now that I've cleared all the multiplication and division, now I can do my addition and subtraction from left to right. All right, evaluate, the root word is value. So we're going to plug these numbers in for x and y, and we're going to get a value for our answer. So you can see we're putting 2 in for x and -3 in for y. So there was already a negative there for subtraction. And so I'm going to replace y with a -3. So that's why we have 2 signs there. And then I'm putting 2 in for x minus 2 in for x and -3 in for y. All right, so now we are going to do order of operations. So we could say 2 times 2 is 4, and then minus a negative is going to be a positive, or you could think of it as negative times a negative is a positive 3. And then down here in the bottom, again, I have to do my multiplication before I do my addition and subtraction. So 2 times -3 would be -6. So in my numerator, 4 plus 3 is going to be 7. And in my denominator, 2 minus a negative, again, remember minus a negative is plus. So that's going to be 2 plus 6. So 2 plus 6 would give me 8. So my answer there would be 7/8. All right, then for number 5, to simplify, we're going to need to distribute this 3 right here. And so I'm going to go through and say, I was trying to get my little arrowhead to come back instead of this line to make it easier for you to see. But -3 times 5 is going to give us -15. -3 times -s is going to give us positive 3s. So we cleared our parentheses by distributing. And again, remember we said the most common mistake people make here is they take the -3 and multiply it by the 5 and get -15, but they forget to take the -3 times the -s, so they would end up with a -3s instead of a positive. So watch out for that. All right, then we're going to combine like terms. So a positive 2s and a positive 3s gives us 5s. And then a -15 and a positive 6 gives us -9. All right, so then for number 6, we want to simplify. And it says that we can have negative exponents in our answer. So we're going to take each of these guys and raise them to that second power. So that would be 3 to the second, x to the negative 3 to the second, y to the third to the second. All right, so 3 squared, of course, is 9. Remember, when you have a power raised to a power, you multiply. So we're going to do negative 3 times 2 is negative 6. And when we have a power raised to a power, we multiply. So positive 3 times positive 2 would be positive 6. Now, this one said we could include negative exponents. If we couldn't, then we would be moving this down to the denominator, but we'll see that in the next problem. All right, so in this next one, they also asked me to simplify, but this time they said we had to get rid of our negative exponents. So I'm going to go through and I'm going to put my p's together and I'm going to put my q's together. So that's what I've done right here. Remember, if I have just a plain p, that's p to the first power. So when my bases are the same and I'm dividing, remember I'm going to subtract my exponents. So that's going to be negative 3 minus 1. So we're going to have p to the negative 4. And then here 4 minus a negative 2. So remember, 4 minus a negative means plus. So you can think of it as negative times negative is positive if you want to, but 4 plus 2 would give me q to the 6th. Since they told me I had to write it without negative exponents, I have to get rid of this negative 4. And to get rid of that negative 4, all I need to do is just move across the division bar. So I'll have p to the positive 4 in the denominator. Okay, so there's my p to the positive 4 in the denominator. And q was already a positive exponent of 6, so it doesn't have to move. So q to the 6th will stay in my numerator. All right, then for number 8, they ask us again to simplify and to get rid of those negative exponents like we did in number 7. So I'm going to put my like things together. So I'm going to put my numbers together, I'm going to put my x's together, and I'm going to put my y's together. So negative 3 times negative 6 would be a positive 18. When your bases are the same and you're multiplying, remember you add your exponents. So 5 and 4 would give us x to the 9th. And again, this y, if it doesn't have a power, remember that's to the first power. So when my bases are the same and I'm multiplying, I'm going to add my exponents. So 1 and negative 7 would give us negative 6. So since I'm not supposed to have negative exponents, I need to get rid of this negative 6 right here. And so to do that right now, y to the negative 6 is in the numerator. I'm going to move it across the division bar and put it in the denominator to get rid of that negative exponent. And so this would be my final answer. All right, then for number 9, they want me to switch from standard form to scientific notation. So remember, with scientific notation, the first number has got to be between 1 and 9. So I'm just going to move my decimal so that my first number would be between 1 and 9. That means I'm going to need to put my decimal right here between the 3 and the 2. That makes my first number 3, which is between 1 and 9. Okay, so there's our 3.2 right there. We can just keep the rest of our values the same. And then in a whole number, my decimal is at the end of the number. So if I want my decimal to be here, you can see I'm going to move it 1, 2, 3, 4, 5, 6, 7 places. So that's how we get the exponent of 7 here. All right. If instead I have a small number, then again, I need to move this decimal so that I have a number between 1 and 9. So it's going to go right here between the 3 and the 2. And so I'm going to move that 1, 2, 3, 4, 5 places. And so I'm going to use a negative exponent for that one. All right, so for number 10, we want to switch from standard form to we want to switch from our scientific notation into our standard form. So if I have 10 to the 5th, that tells me that I'm going to take this decimal and I'm going to move it 5 places. So if it was right here, I'm going to move it 1, 2, 3, 4, 5 places, and that would be my standard form. If it's a negative exponent, my number is going to get smaller. So I'm going to take this decimal and I'm going to move it 3 in the opposite direction. So 1, 2, 3. And so if it was right here and I move it 1, 2, 3 places, I'm just going to put in 0 placeholders. Now, remember the discussion we had in class about using logic on these instead of just trying to memorize, which way to move it. Remember, if we use logic and think about 10 to the 7th as a 1 with 7 zeros after it, that's a huge number. If you multiply anything by a huge number, it's going to get bigger, right? So that way you can kind of use logic to check your answer and make sure that you have the right exponent, whether it's positive or negative. All right, then for number 11, we've got the square root. And so I'm going to start off with 12 and I'm going to prime factor it down. So 12 would be 2 times 6 and 6 would be 2 times 3. Remember, you have to have a pair to take it out from under the square. So I had a pair of 2's that I could take out, but I only had 1 3, so I can't take it out. It's going to stay. All right, so this square root of 12 is going to be 2 square roots of 3. For a cubed, that's a times a times a. So I have a pair, I can take it out from under the square, but this other one's going to have to stay underneath. For b to the 4th, that's b times b times b times b. I have a pair, it can come out. I have a pair, it can come out. So that would be b times b, or b squared. And then I only have one c, so since I don't have a pair, it has to stay. All right, so let's go through and let's collect everything that's on the outside. So I would have 2ab squared on the outside. And then on the inside, I've got the square root of 3 and the square root of a and the square root of c. So square root of 3ac would be left on the inside. All right, for number 12, I want to try and add and subtract here. And to do that, I have to have like radicals. So remember, that means that it has to be the exact same radicand, the number under the radical sign, and it has to be the same index, like each one of these is a square root. So if I simplify, like right now, 20 and 5 and 45 aren't the same radicand, but if I simplify, I might end up with like radicands. So I'm going to take this 20 and come over here and prime factor it. So that's going to be 2 times 10. 10 is 2 times 5. So if I have a pair, I can take it out from under the square. That 5 is going to be left underneath. And then 45 is 5 times 9, and 9 is 3 times 3. So I have a pair of 3's I can take out, and my 5 is left underneath. All right, so over here for 20, we already had the 3. And then for 20, we got 2 square roots of 5. So there's my 2 square roots of 5. Now, see how that 3, there was no symbol between the 3 and the square root? Remember, when there's no symbol in math, that means we're multiplying. So that's going to be 3 times whatever I got for the square root of 20, and I got 2 square roots of 5. So that's going to be 3 times 2 square roots of 5. All right, then this guy we're leaving alone. And then for square root of 45, remember that we took out a 3 and we had a 5 left underneath. So we take out our 3 and we've got a 5 left underneath. So 3 times 2 would be 6. So now I have 6 square roots of 5 plus 4 square roots of 5 minus 3 square roots of 5. Remember, with these, we're going to combine our coefficients and leave our radical exactly the same. So 6 plus 4 is 10 minus 3 is 7. And then we're going to leave that square root of 5 exactly the same. All right, and then last for number 13, we're multiplying these two radicals. So I'm going to first off break these apart into separate pieces. So I'm going to say square root of 6 times square root of w cubed. Square root of 15 times square root of w to the 5th. Then I'm going to collect the things that are alike. So I've got my numbers over here and I've got my w's over here. So 6, of course, is going to be 2 times 3. And 15 is going to be 3 times 5. So that means that here I've got 2 times 3 times 3 times 5 with these two guys right here. So I have a pair of 3's. I can take out a 3, but the 2 and the 5 would be left underneath. So 2 times 5 would be where my square root of 10 comes from. All right, then over here I had 3 w's, 1, 2, 3. And I had 5 w's, 1, 2, 3, 4, 5. So when I'm multiplying those and I put them all together under the radical, there's a pair, there's a pair, there's a pair, and there's a pair. So I can take out 1 w, 1 w, 1 w, 1 w. So that's where we got this w to the 4th. So now if we collect everything that's on the outside, the 3w to the 4th, and we leave the things that are on the inside, the square root of 10, then that would give us our answer. So there is nothing on your quiz tomorrow that is not on this sample quiz. Not everything will be on your quiz tomorrow, but if you just know how to do everything on this sample quiz, you'll be all set for your quiz tomorrow. I know you're going to do a great job. All right, love you guys. Have a good night.